Hey everyone, welcome to the channel. So in this video, I will not really talk about any specific math topic. Rather, I will do a book review, or more specifically, I will do a math book review. The book is called The Art and Craft of Problem Solving by Paul Zeitz. And this book is one of my favorite books ever, regardless of the genre. To give you an idea of how favorite this book of mine, when I was leaving my country to come abroad to study, so I wanted to bring some book with me, right? And the limit of the luggage, the weight limit of the luggage was around 30 kilo. So I couldn't really afford to take a lot of books with me, and so I took 3 or 4 books with me, and this was one of the books that I brought with me while coming here in abroad. So yeah, this should give you an idea of how much I like this book. So this book is a book about problem solving. Of course, I mean, from the name maybe you can deduce it. And there are a lot of really good books on problem solving, right? There is a book called Problem Solving Strategies by Arthur Angel. There is a book called Problem Solving by Solving Problems. I think this is the title, by Lauren Larson. But this book is very unique in the sense that this is probably the only book that talks about the psychology of problem solver. All right. I did not really find any other books that talk about the psychological aspects of problem solving. It could be math problem solving, it could be any other type of problem solving, right? So yeah, this is why I think this book stands out. And so let's have a look at the table of contents. So as you can see, there are 9 chapters in the book, and the first chapter is called what this book is about and how to read it. This is a very important chapter, even though from the name it could seem that maybe you can skip it, but actually this is a very important chapter. And there are 2 important subsection of this chapter that I want to point out. The first subsection is called exercise versus problem, where the author Paul Zeitz, he kind of distinguishes what is the difference between exercises and the problems. And the second subsection is also really important, the 3 levels of problem solving. And then the second chapter, strategies for investigating problem, which is really important chapter. And the third chapter, tactics for solving problems, right? And then the 4th chapter called 3 important crossover tactics, so where he talked about graph theory, complex numbers, and generating functions. So these are these 3 fields, even though they're 3 separate fields, graph theory, complex numbers, and generating functions. These branches are very handy when it comes to solving problem that are very unrelated to these branches. So let's say solving algebra problem or geometry problem. These 3 branches comes very handy. You can use the idea from graph theory or complex number and generating function to solve some problems in some other branches of mathematics. And then from chapter 5 to chapter 9, they're very specific subject oriented. So there is chapter 5 is about algebra, chapter 6 is about combinatorics, which is the branch of math that studies counting techniques, and then chapter 7 is about number theory, chapter 8 geometry for Americans. It's a very sarcastic title. And the last chapter of the book is called calculus. It's about calculus. Okay, so in my opinion, the whole book is a magnum opus, and even the original, it was written for math Olympiad student to prepare for mathematics Olympiad. It could be international mathematics Olympiad, it could be some really high level math competition. But I think this book is really handy for anyone who works with problem solving. If you are a math undergraduate student, if you're doing your bachelor in mathematics, I think it's a really useful tool to learn how to solve problems. And even if you're not studying mathematics, maybe let's say you're studying physics or you are studying engineering, I think you should at least go through the first 3 chapters. I mean, if you are a math student, I would recommend you to go through the whole book. But if you are physics or engineering student, I would highly recommend you to at least have a look at the first 3 chapters. Maybe you can skim through it, just to see what are the topics are about. Chapter 1, chapter 2, and chapter 3, or more specifically chapter 2 and 3. They're really important chapters. In these 3 chapters, Paul Zeitz talks about some really important psychological aspects, or not just psychological, but also general aspects of problem solving. For example, as I already mentioned, in the first chapter, he talks about the difference between exercises and problems. So normally the problems that we solve in school or college, most of them are actually really boring exercise. They're not really problems. According to Paul Zeitz, exercise are the problem that you exercise are the kind of problem. Let's say exercise are the kind of exercise that you already know how to do. For example, if someone tell you to multiply 541 with 390, right? You can do it, but it will be very tedious. It will take you some time to do the calculation, do the multiplication by following the standard procedure, right? This is exercise. Exercise is something that you know kind of how to do, but it's a bit tedious. On the other hand, problems are more interesting. Problems are the kind of exercise that you don't really know how to approach at first. That makes it more interesting. So you have to think like how to approach the problem in the first place, right? So in this first 3 chapters, Paul just really talks about like how to approach the problem, so general strategies of how we should tackle the problem, right? When you don't know how to begin with the problem. So the second chapter and third chapter, the second chapter strategy for investigating problem, and third chapter tactics for solving problems. In this 2 chapter, Paul just talks about all the psychological and general strategies, general methods even, that you need to kind of attack a problem, right? So which is, I think, is very important. I remember once I was kind of tutoring one of my students, and he was asking like, because I was helping him to solve a problem, and then he was like, because you already know that how to solve this problem, that's why it's easy for you. But if I don't know how to start the problem, which trick to use, how would I think about it, how would I start with the problem, right? If I don't know where to start. So I think this book is really a good resource for if you're one of this kind of person who don't really know how to start a problem, how to investigate a problem, right? There is a big part of problem called investigation. Normally the problem that we solve in school, these are not really that hard. These are very routine, boring exercise. So you don't really have to think about it as much. But when you solve Olympiad problem, Math Olympiad problem, you'll see they are not very straightforward. You have to use your imaginative thinking and creative thinking to solve problems. So in the first chapter, Paul Zeitz talks about 3 levels of problem solving. He kind of divided different things that you need to solve problem, different kind of tools. So the first thing that he said that we need is called strategy, like general strategy. It could be psychological strategy, or it could be in general, like general strategy problem solving. The second level of solving problem is called tactics. He said it's to be tactics. Tactics are probably more mathematical. These are not necessarily mathematical formula or theorem. These are more mathematical methods. So I think Georges Paulois said it, mathematician Georges Paulois. He said that, I don't really remember the exact quote, but he said something like, if you can use something, a trick, if you can use something for once to solve the problem, it is a trick. But if you can use it multiple times, it becomes a method. So those are the things, like in the chapter tactics of solving problems, Paul Zeitz talks about all those methods, mathematical methods that you can use to solve the problem. So the first step of solving problem is the general strategy, and then tactics, and then the last part is the tools. And from chapter 5 or from chapter 4 to chapter 9, he talks about all the tools. What are the tools? Tools are all the mathematical stuff that we know. It could be theorem, it could be mathematical formulas, a mathematical identity, all those mathematical equation, all those very specific mathematical results. Those are the tools. So there are 3 different layers: strategies, tactics, and then there is tools. And another example that he gave regarding the difference between exercise and problem, I just want to mention that, is that he said that exercise are very similar to going to gym. You're just going to the gym, and it's a bit tedious sometimes because you're going to the gym, you're doing routine exercise, and then you know the outcome. If you know that if you do it consistently, you already know the outcome. It's not very exciting because there are not a lot of risk involved in it. On the other hand, solving problems are very similar to mountaineering, because in mountaineering there are a lot of risk. There's a risk of death. You can actually die, because, and also you don't know. Let's say you're trying to, go on the top of a mountain. You have to do a lot of planning, how to go, what is the best route to go on the top of the mountain, and sometimes if you take the wrong approach, you can die. So there are a lot of risk involved in it, but at the same time, the reward is also higher. You will feel much better once you achieve those things compared to going to the gym. So yeah, that's, I think, it's a really good example. In chapter 2 and 3, he talks about more specific strategies and tactics of problem solving. So in chapter 2, he talks about the psychological strategies and also the general strategies of problem solving. Some of the example that I can give is like, for example, he talks about mental toughness, how to build mental toughness. Or for example, another strategy is getting oriented with the problem. So when you read a problem first, the first step should be to understand the problem really well. It seems very trivial, but a lot of people actually don't do that. And another thing is make it easier strategy. So if you see a problem and it seems very hard to you, try to reduce the difficulty of the problem by tweaking some parameter and try to solve the easier version of this problem. While doing that, it's possible that you will see some sort of pattern that will help you to solve the harder version of the problem, right? And then there's another strategy called make your hand dirty. That means, let's say if you're working with a general hypothesis, try to work with the smaller cases. Try to work with the smaller case and see what happens, and maybe it will give you will see some sort of pattern that will help you to get an idea to how to tackle the problem, right? So these are general strategies of tackling the problem. And then in chapter 3 talks about more specific tactics. These are more of a specific mathematical method. Like there is a one called extreme principle. He talks about extreme principle, which is, I think, is really interesting idea. I think a lot of people don't know about it, but I think it's very powerful idea. And then they talks about symmetry, the idea of symmetry in solving math problem. And then he talks about the pigeonhole principle, which is more of a specific mathematical result. I think it comes from combinatorics, but you can actually use it not only in combinatorics but also in some other branches of mathematics for solving problem. And the final thing he talks about invariant, so which is also very important mathematical method, mathematical tactics that you can use for solving problem. So these are all the tactics. I mean, there are a lot of other tactics that he discussed, but those are the most prominent ones. So chapter 2 and 3, in chapter 2 he talks about the strategies, and chapter 3 talks about the tactics, and from chapter 4 onwards until chapter 9 he talks about all the specific tools. So I will highly recommend you to go through at least from chapter 1 to chapter 3, the first 3 chapters of this book. I think you will have a really different view about what mathematics is all about, and not just mathematics but also how to approach problems both in your studies but also in real life, real life problem solving. So yeah, that's all I have to say about this book. I think it's one of my favorites ever. I already mentioned it. So yeah, I mean, if you can get a hold of this copy of this book, just get it as soon as possible, and I think it will change the way you look at a lot of things. Yeah, so yeah, that's all. Thank you so much for watching, and I'll see you soon.